Hello everyone, welcome to IAS Baba's 60 days rapid revision series for Prelims 2022. This is day 32 and we have geography again. So the topics related to soil and natural vegetation in India we discuss here. So first one, the soil texture. So on the basis of the size of the particles of soil, so we have sandy soil, clayey soil and then the laterite soil and others. So first one is the sandy soil. So here the particles of sand are bigger in size. So that is why this is highly porous and also the permeability of sand is high. Say for example, if water falls, so it permeates immediately. So here the fertility of the sand, it is more. So NCERT says that is, if the sandy soil is well irrigated, we can grow good number of crops in this sandy soil. So we go with the NCERT and then come to next the loamy soil. In the loamy soil, most of the sand, then the clayey soil and then the gravels, so all these are mixed together. So here we cannot say a definite particle size. So this is the soil which is present in most of the parts of the world, and here the soil is also having a good potential for agriculture, and this soil is also used for the construction of burns and others. So this is all about the loamy soil. Then next, clay soil. So here the clay soil is having a very finest particles, so hence it is having least porosity. So that means water will not seep in immediately and water will be stored, and hence we can get such fine layers like this, polished layers, and it is having least permeability. So whenever least porosity is there, the permeability will also be lesser. Then come to next, the laterite soil. So here, due to excess of rainfall, the finer particles of the soil have been eroded and we have only the hardcore bases, and these soils, so they are hard and they are fit for the construction. So in coastal areas and in the areas where there is more rainfall, so these soils are used for the construction. They are used as equivalent materials for bricks. So they are being cut and the bricks are being used. So here we can see how the bricks are being formed from the laterite soils, and these laterite soils, so they are having least fertility, and we remember those. Then come to next, the distribution of soil in India. So in India we have various kinds of soil as per the geographical indications, and the most expansive ones are the red soils. So here we can see the red soils which are present in most of the Deccan Plateau and also in eastern India, and it is red because it contains the hematite ore. So we remember the hematite ore. And then the black soils, so we also call this as the regur soil, and this regur soil is formed due to the fissure volcanoes. That means large fissures that occurred in this Maharashtra region, and these fissures, they started oozing out the volcanoes. So that is why due to these volcanoes the igneous rocks came out, and these rocks, they formed the black soil, and it is very good for cotton cultivation. And apart from this, we have the alluvium soil. This alluvial soil is present in most of the delta regions and also in the Ganga Brahmaputra plains. So these are the fine soils, and here most of the agriculture activities can also occur. And also remember, this red soil or the hematite soil is present in most of the parts in northeast India also. Then here in the Jammu, Kashmir and Himachal region, so we call it as the mountain soil. So this mountain soil is characterized by the deposition of the glaciers and others. So that is why it is a bit different, and it is also characterized by rocks and also the finest particles. And then the desert soil. So desert soil is nothing but the sand. And apart from that, we get the laterite soils in the rain-fed regions of Western Ghats and in the West Bengal Jharkhand border, and also in Meghalaya and Assam regions. So these are the soil distribution. And friends, apart from this, we have to study also which soil has the nutrients and which soil is poor in which nutrient. So that we will take up in another class. So as of now, we go with the distribution. Then come to next, the natural vegetation in India. Friends, here unlike the world's vegetation, which is exactly stratified as per the various categories, here we don't get proper categories. So we will discuss how various categories are present. First we go with the tropical evergreen forests. So only those parts of India where the rainfall is huge, that is we get some 8 months of rainfall, we get the tropical evergreen forests. So they are present mostly in the southern parts of Western Ghats and also in the northeast region. So here the rainfall is huge, that is why these forests are very much similar to the tropical evergreen forests of Congo or the Amazon. And then we get the tropical deciduous forests. So these tropical deciduous forests are majorly present in India. So these tropical deciduous forests, so they are of two types, that is the tropical moist deciduous and the tropical dry deciduous. So what is the difference? So in the tropical moist deciduous, So here the rainfall is for 7 to 6 months, and in the dry deciduous the rainfall is just for 5 to 6 months. So here the dry season is more for the dry deciduous. So what are the regions? So in the upper parts of Western Ghats and also in other parts of Assam and the northeast, we will get the tropical moist deciduous. So here in the Karnataka region and Maharashtra region, the sandalwood is the typical tree that is found in the tropical moist deciduous. And then as we move eastwards in the Eastern Ghats and also in parts of Andhra Pradesh, Telangana, etc., we get the tropical dry deciduous. So these dry deciduous, here we have the red sandalwood. So this is the famous one for the dry deciduous. And apart from these tropical evergreen and deciduous forests, we also have the grasslands which is spread in vast expanses in India. So the grasslands might be either savanna or steppe, and we don't get the proper clear demarcation. So in most of the central part of India, we have the savanna and the steppe type, and but obvious in the plains of Ganga Brahmaputra, we also get the grasslands, and we also have some forest densities in Jharkhand and Odisha regions. And apart from that, we also have the semi-arid and arid type of vegetation. So as and when we move towards the arid parts, say for example this part, and also in the Rajasthan and the Jaisalmer part, so we have the arid region. So as and when we approach towards that, we will get the semi-arid vegetation. So here in the semi-arid vegetation, we will get both the thorns as well as leaves in those plants. Say for example babul and others. So they have both leaves as well as thorns, and after that the leaves will decrease and then we have only the thorns. And apart from these, we also have the temperate forests. Temperate forests are not present so much in India, but only on the slopes of Himalayas we get these temperate forests. So we know that temperate forests are the spruce, fir, junipers, so oak, etc. So they have a very needle shaped leaves, so they are being adopted for a very least moisture, and that is why we have them. And we also have some of the coniferous trees as and when we move in the upper altitudes in the Himalayan slopes. And apart from these, so here we have one more type of vegetation which is unique to India, that is the broad-leaved vegetation. So what is a broad-leaved vegetation? Like as and when there is a sudden change from the plains to the forests. So here in the UP region, it is a plain, and as and when we climb towards the Himalayas, so in the Terai region and others, so there is a sudden shift in vegetation from grasslands towards the forests. So there, instead of getting a temperate forest at the first instance, we get this broad-leaved vegetation. So here, the leaves of these trees are broader compared to those in the temperate region. So the temperate regions we discussed, they have needle-shaped leaves, but here the leaves are broad-shaped. So best examples are the oak, walnut, chestnut and these. So that is why this broad-leaved vegetation, so that is again unique to this area because of the sudden shift from the grasslands towards the up in the altitude temperate forests. And apart from this, we have the mountain vegetation, that is as and when we move upwards in the altitude, we get the rhododendrons after the temperate forests. So rhododendrons, we know they are made up of colorful flowers, and after that we get the sedges. Sedges, we know these are the shrubs, so that are made up of the white flowers, so there we don't get the color, and after that we get the mosses and the algae. So this is the highest. After that we get only the snow peaks. So here remember all this because many questions have come on the vegetation of India. So we take up some of the questions here. We look into this one. Which one of the following national parks lies completely in the temperate alpine zone? So the alpine zone we are searching here. So but obvious, we have this valley of flowers as the answer. So why this valley of flowers? Say for example, we have discussed in the northeast. So we have this tropical forests. So tropical forest means we will exclude those which are present in the northeast. So Manas is in northeast, Namdapha is in Arunachal Pradesh, we can exclude them, and then only the competition is between Neora Valley and the Valley of Flowers. So this Neora Valley, so it is much southern compared to Kanchenjunga. So Kanchenjunga, we know it is having completely alpine vegetation, but very southwards of Kanchenjunga, so there is a drastic decline, and Neora Valley lies to the much south of Kanchenjunga. So not alpine and Valley of Flowers, that stands to be the formidable answer here. Then one more, which one of the following national park has a climate that varies from tropical to subtropical and then to temperate to Arctic? So all types of vegetation should be present. So here when we see the options, that is Kanchenjunga, only temperate is there, then Nanda Devi and Neora Valley. So here the tropical evergreenness or the hardcore tropical forest is not found. So only in Arunachal Pradesh we can have that tropical again. So that is why Namdapa. So that will be the formidable option. So friends, we will be having a very exact conviction, that is, this is the exact answer. So if you have studied properly, so these questions will never go wrong. So make sure that you will study likewise, and when you attempt the exam, so attempt in such a way that you have a strong evidence behind marking an option as either correct or wrong. Then come to next, the important mega solar projects of India. So here we have some of the projects which are largest in the world. So that's why it is worth discussion. So Pavagada Solar Park, so in the Shakti Sthal of Karnataka. So Shakti Sthala or Shakti Sthal of Pavagada Solar Park in Karnataka is one of the world's biggest solar farms, and this is spread over 13,000 acres, and it can harness some 2000 megawatts of power. And here we can see how these solar plants are being set up beautifully. And then come to next, Kurnool Ultra Mega Solar Park of Andhra Pradesh. So it is in Kurnool, and here this is spread over some 6,000 acres. So it is in Andhra Pradesh, and here there is no confusion. We all know Kurnool, which is a famous place. Then Kamuti Solar Power Project, Tamil Nadu. So Kamuti is the third largest solar park in India and also the sixth largest in the world. Then Badla Solar Park of Rajasthan. So this is spread over a total area of 10,000 acres, but its capacity is only some 2000 megawatts. So that is why it is standing in the 5th place in India. Then come to next, Charanka Solar Park. So Charanka Solar Park, so this is having 790 megawatt capacity, and earlier it was the world's third largest photovoltaic power station, but now in India we have many parks which are harnessing much more energy than this. So these are some of the mega solar projects of India. Then come to next, shale gas and gas hydrates. So firstly, the shale gas. So shale gas refers to the natural gas that is trapped within the shale formations, and lately shale gas has become an important source of fuel in United States. So we all know that United States, it lately entered into the market and now it is dominating, and shale gas is extracted through a method known as hydraulic fracking, so mostly known as the fracking. So here we can see in brief how this fracking can occur. So friends, here the shale gas is present mostly in the horizontal rocks. So that is why first we dig vertically and then the horizontal digging begins. And once the horizontal digging goes, and here we will inject the water and other chemicals forcibly. And when the water and other chemicals, when they occupy the space here, so the gas hidden in this space, they will rush out into the pipe and they will be extracted in this part again above the earth surface. So this is how the hydraulic fracking occurs, and this is how the shale gas is being extracted. Then come to next, the gas hydrates. So they are formed when a gas such as methane gas, so that is trapped in a well-defined cages of water molecules forming crystalline solids. So here it is not about the horizontal rocks. So these are being trapped within the water molecules. So like within the ice, these gas molecules are being trapped. And then this is a solid ice-like form of water that contains gas molecules, and natural gas hydrates occur on continental margins and shelves worldwide from polar regions to tropics. So here in the continental margins, that is might be in the Greenland and the northern Russian regions. So there we can see these gas hydrates more, and they are generally associated with biologically rich cold seep ecosystem at the seafloor. So what is this cold seep ecosystem? These are the locations where the hydrocarbon rich fluid seeps from below the seafloor, often as the methane or hydrogen sulfides. So it happens like this, that is in the ocean floor, as and when the methane will emerge. So this methane, it will mix with the water, and this dissolved methane, so that will be trapped in the ice. So that is how the gas hydrates are being formed. So remember these two, and then come to next, the salinity, alkalinity and acidity of soil. So friends, this is also worth discussion. So here in dry climates, NCERT says that the soil is always alkaline, but as and when the wet climate arises, soil turns acidic. So that means if you add more and more water, if the soil becomes more and more marshy in nature, so the acidity increases. Say here the methane and other gases will be emitted, and these gases, so they will mix with water and they get converted into the carbonic acids, and due to the excess of acidity, so they will become unsuitable for agriculture. So that means if I am irrigating the land more and more, so after some time the soil becomes acidic. Now in order to neutralize this acidic, our farmers, they add calcium. So that is the calcium oxide, CaO, or the lime. Lime is added, and due to the addition of lime into the soil, now the acids and bases, so they got neutralized, and due to that the salinity of the soil increased. So again, when we say that the chemicals and other fertilizers, they increase the salinity of soil, that is because due to addition of the calcium oxide. Now the salinity is being increased, and now to decrease the salinity of the soil, we are adding gypsum. So how this gypsum works? Friends, this gypsum, it is having some water holding capacity. So whenever we add gypsum, so it stores water or it holds water in the soil, and when the soil is holding water, most of the soil, so that will dissolve the salts that is present here. And once this is dissolved, now if I add fresh water, so all this water will be flushed out and the salinity will be reduced. Okay, so the saline water that will be removed out or skimmed out from the soil. So this is how gypsum can reduce salinity. But in UPSC there was a question like, which of the following practice can help water conservation in agriculture? So here UPSC gave 1 and 3 only as the answer, and applying gypsum before irrigating. So this was not the answer, because gypsum is used to reduce salinity, not to conserve the water. So remember these things. Then come to next, soil fertility management techniques. So friends, every year sustainable agriculture. So from here many questions will come, and some of the keywords which are not so familiar will be picked up by UPSC. So here I have some of them. Key line design. So what is a key line design? It is more enhanced version of contour plowing, and maximum water retention is achieved by taking into account all watershed properties when making the contour lines. So when we are doing the contour plowing, we are not just doing it crudely, we are using some advanced techniques and technologies, and then finding out the contours, how to plow. Then perimeter runoff control. So this is the practice of planting trees, shrubs and the ground cover over the perimeter of the farmlands. So around the farmlands, if I grow vegetation, that can curb soil erosion and degradation. Then agrostological measures. So what is this agrostological measures? It is planting grass in heavily eroded areas. So agrostological means the growing of grasses, a simple one. Then come to next, reduction of impervious surfaces. So what is this impervious? So which surface we have metallized, which have put concrete, which we have put tiles. So all these are impervious. So if water falls on these impervious surfaces, so now the water content will be huge, and this gushing water that will take away all those particles if this falls on the soil surface. So that is why if we make sure that we reduce these impervious surfaces, so water whichever it falls, it will be sinking at that place, and this will not only reduce the soil erosion, but also it will increase the groundwater table. So the borewells in the cities are being drying because of the lack of groundwater table. So if you remove concretization, so we can improve the water table. Then the rain gardens. So here a rain garden is a shallow depression in the land which holds and collects running water from impervious surfaces and prevents erosion while saving the nutrients. So here it is like some depressions are being made in the mountain slopes or in the plains, so that here the grasses will be grown, and these grasses, they will hold water and also the topmost layers of the soil. So this can be done by digging simple sinking pits. So on the mountain slopes, we have dug many sinking pits. So that can also be one of the examples for these rain gardens and others. So these are some of the ones. Then come to next, the important glaciers of India. So continuation from the last class, that is the Barashigri Glacier. So this glacier feeds the Chandra River in Lahore and Spiti Valley, so in Himachal Pradesh. So we also have the famous Lahore Spiti Road, the highway. So just locate this in the map and also locate the nearby regions. And then Zemu Glacier, it is the largest glacier in Eastern Himalayas and is located at the base of Kanchenjunga. So remember this, and this is not present in the Kashmir Himalayas but in the eastern ones. Then the Drang Drung Glacier. So this mountain glacier is known as the Drung Glacier and it is located in the Kargil district of Ladakh. So again we came back to Kashmir Himalayas or the Ladakh Himalayas. Then Milam Glacier. So it is a major glacier of Kumaon Himalaya. This glacier serves as a popular trekking destination. So Kumaon Hills, Kullu, Manali, so all those important tourist places we remember. Then Machoy Glacier. It is the source of Sindh River and Dras River. It is located in the northeastern Himalayan region. So this is an assignment. Locate all these in the maps and also locate the Sindh River and Dras River and find out they are the tributaries of which other rivers. Then distribution of coal in India. So how to study these distributions? Friends, for prelims perspective, just make sure that any important mines if you have, that if you revise, that is more than sufficient. So UPSC will never ask a question like whether coal is present in Maharashtra, Jharkhand, Uttarakhand or not. So we cannot say with conviction that coal is not present in Uttarakhand. Even if 1% is present, UPSC will go wrong. So such questions are insane. So think from the examiner's perspective, just locate some important mines, and also if some mines are in news, just locate them and revise them. That is more than sufficient. So here the distribution of coal, the Damodar Valley project. So here Jayanti, Bokaro, then Karanpura, Ramgarh, Girdi, Auranga, Hutar, then Daltoganj and Deoghar. So here don't by heart all these things. So just go to the map and locate all these districts. So you will have a command over the map works. So again it will be a double advantage. Then West Bengal's major coal fields are Raniganj and Dalingkot and Darjeeling. So locate them. And then Mahanadi Valley. So here Korba, Jilmil, Chirmiri, then Bishrampur, then Lakhanpur, Birampur and Sonhat. Then Sun Valley Coalfield, Singrauli, Sohagpur, Umaria, Pench, Ramkol and Tatapani. So these are some of the ones. And then in the Godavari Valley, we have Singreni, Tandur and Shasti and Wardha. Here we have Kamti, Onefield, Chandrapur, Yavatmahal and Nagpur. Then Satpura Coalfield, so Gorbari, Mahapani and Patarkheda. Then Rajmahal Coalfield, that is Lalmatia, is a major coal mining center in Rajmahal range where open cast mining is practiced. So we have the quarrying, shaft mining, open cast mining, so all those different minings, so simple concepts. Then some of the important mines. So here we have the Korba and then the Raniganj, then Talcher mines and Jaria, then Bokaro. So we remember Sonepur. So these some of the ones if you remember. So just which will come in which state or which is a district in which state. So that is more than sufficient. So that knowledge is enough for both prelims and mains. Even in the mains, so just if you leave 1 or 2 examples, so that is more than sufficient. You need not write 100 examples. So just some 8 examples or even 5 to 6 will suffice. Then come to next, distribution of iron ores in India. So again we go with the same approach. So some of the famous mines. So the regions again the same, the Jharkhand region, Chhattisgarh region, then the Goa and Karnataka region. So these two we know because of the illegal iron ore mining that was present some 3 to 4 years back. And now some of the important mines. So here we have Sundargarh, then Mayurbhanj, then Kendujar, and then we have the Chandrapur, Bailadila mines. Durg is present here. So Raipur, Durg, Baskar. So these are the Naxal hotspots. And then in Goa we have Ratnagiri, and then Goa again, and then Bellary, Tumukuru, and then Chikmagalur, and then Kudremukh. So all these, so important places in Karnataka region, and also Chitradurga. So just go to the map and locate all these, so in which district, and also see the nearby places. So that is more than sufficient. Then come to next, the Loktak Inland Waterways project. So again current affairs, the Ministry of Shipping gave approval for the development of the Loktak Inland Waterways Improvement Project in Manipur under the Central Sector Scheme. And in this context, we study about Loktak. Loktak has been asked 3 to 4 times in UPSC. So it is the largest freshwater lake in northeast, located in Moirang district in Manipur. And this lake is known for its circular floating swamps called the Fumdis. So they are circular and they are floating. So remember them. And if you just hit the Fumdis or the Loktak in Google, you will see these circular floating grasses. Then the term Fumdis refers to a collection of heterogeneous mass of vegetation, soil and inorganic matter. So just like how the seaweeds and others are floating, so the same way it floats. So it contains both the living and dead biomass. Then Sengai is the state animal of Manipur. So Sengai means the bro-antlered deer, and the hooves of this Sengai is adopted for the walk on Fumdis. So they can walk easily. All other deers they can't walk. So that is why this bro-antlered deer, so they were also asked 2 to 3 times in prelims. So remember them. Then the lake is now endangered with innumerable threats like pollution, decline in the diversity of avifauna and thinning of Fumdis, etc. So this lake is also present in the Montreux's record. So Montreux, so this Montreux's record of the Ramsar. So this was also asked by UPSC once. So remember, so among those Ramsar wetlands which are in the verge of danger, so those will be put into the Montreux's record. Then the team will enumerate the steps required to be initiated for declaring Loktak Lake as UNESCO World Heritage Site. So remember this, and also remember that the Nokrek, that is in Meghalaya, very next to the Manipur. So that is present in the UNESCO World Network of Biosphere Reserve. So this is now going to become the UNESCO World Heritage Site. So what is the difference between the World Network of Biosphere Reserves and the World Heritage Sites? So that is also worth to be seen and revised. Then come to next, the Super Typhoon Rai has hit Philippines. So here the Super Typhoon, what is it? The typhoon and hurricane are the two of regionally specific names of tropical cyclones. So this we all know. And in the North Atlantic, Central North Pacific and Eastern North Pacific, so these are called hurricanes, and in the Northwest Pacific it is typhoons. So now for us, what are the super typhoons? So since 2009, Hong Kong Observatory has divided typhoons into 3 different classifications. So remember here the Hong Kong Observatory, and here the typhoon, severe typhoon and the super typhoon. And a typhoon has a wind speed of 118 to 149 km per hour, and a severe typhoon, so that is 150 km per hour, and a super typhoon 190 km per hour. So it is only on the speed of the cyclone on which the categories are being made. So mark Hong Kong and the speeds as important ones. Then come to next, the Deendayal port or the Kandla port. So it crosses the 100 million mark. So what is this 100 million mark? That means it has the ported and deported some 100 million metric tons of goods by now. And Kandla, officially the Deendayal port, is a seaport located on the Gulf of Kutch. So remember this, the Gulf of Kutch and Gulf of Kambat. And between these two, we have the Saurashtra, and here we have the Run of Kutch. Now, a brief account on the Gulf of Kutch. The Rukmavati river empties into the Arabian Sea nearby. So here very nearby, the Rukmavati river empties. So locate that in the map. Then renowned for extremely daily tides. So the daily tides, they are in extremes, and hence it is having a high potential for the tidal energy. And then come to next, this Gulf of Kutch is referred to as the Gulf of Baraka in the Periplus of Erythraean Sea. So this is a travelogue of 15th century AD. So in that Periplus of Erythraean Sea, so this Gulf of Kutch is called Gulf of Baraka. So remember the historical names also. So here the first coral garden will be set up near the Mitapur in the Gulf of Kutch. So mark this first as important, and the coral garden. And then the dugong, the vulnerable species, is also present here. So dugong are mostly present in the Park Bay. So they are present in the Gulf of Kutch also. Then come to next, Indonesia relocates capital due to rising sea levels. So here the Indonesia's parliament has passed a law approving the relocation of its capital from the Jakarta, which is sinking, to the island called the Nusantara. So here we can have the brief look into the Jakarta. So here it is, and the new capital Nusantara will be here. So Nusantara will be very nearer to the Borneo. So Nusantara will be on Borneo. So friends, there was a UPSC map question regarding this Java and Sumatra. So which of the following will be very nearer to India? So this is worth revision for the map work. So locate Java, Sumatra and the Borneo here, and locate Malaysia, that is present in these two regions. So that means South China Sea is separating Malaysia into two land masses. And also remember the Sulu Sea, Celebes Sea, and then Sulawesi, and then the Timor Sea here. So Banda Sea, Arafura Sea also we can remember. So that was about Indonesia. Then the sea level rise. So it is induced by 3 parameters. One is the thermal expansion, and then the melting of glaciers, and then the loss of Greenland and Antarctic's ice sheets. So these are the 3. And again, whenever the UPSC asks such, go with the inclusive approach. That means include as much as possible unless and until they are extreme. Then sea level is primarily measured using the tide stations and satellite laser altimeters. So mark these two as important. Tide stations we know, then satellite laser altimeters means, so in these altimeters to what height the sea level has risen, so that we can see. Then global sea level has been rising over the past century, and the rate has accelerated in the recent decades. So this year also we have seen the record high temperatures. So again worth remembering. Then come to next, the Vishnuonyx. So newly found fossils of Vishnuonyx have been found in the area of Hammerschmidt, which is a fossil site in Bavaria of Germany. So this Vishnuonyx is found in Bavaria, Germany, and here the fossils of these now extinct otters were first discovered in sediments found in the foothills of Himalayas. So these were found in Himalayas and now they are found in Germany. So how they went from Himalayas to Germany? So that is the point of question. and now the newly found fossils indicates that it had traveled as far as Germany, and the newly discovered fossils have been named the Vishnuonyx neptunei. That means the Neptune's Vishnu, a mythological name. And then this is the first discovery of any member of Vishnuonyx genus in Europe. So first time we have discovered this genus in Europe, and this is also its most northern and western record till date. So to that north and to that west, so the Vishnuonyx fossils have never been found till now. So this is the first one. And now about Vishnuonyx. So these were the mid-sized predators that weighed on an average 10 to 15 kg. So a considerably small one. Then before this, the genus was known only to Asia and Africa. Then Vishnuonyx depended on water and could not travel longer distances over the land. And how it traveled as far as Europe? So here, according to researchers, it travels over 6,000 kilometers, were probably made possible by geography of 12 million years ago. So by that time, the geography was different. So that is 5. So now, how could it travel as far as Europe? So we know that it cannot travel faster in land. So how? So that means it had got a safer water connection. So in that 12 million years ago geography, so there was no Alps. So Alps was about to rise, and here these Alps and Iranian Alps, so they were separated by ocean basins. So this ocean basin that provided a safe connectivity for this from the Indian Ocean to till the Mediterranean Sea, so that it can enter Germany. So that is how with these ocean waters it has traveled. So this was all about today. Then coming to the last part. Friends, as the saying goes, knowledge is power. So don't study for the sake of exam or the perks and privileges you get after clearing this exam. So study for the sake of knowledge, because the knowledge citizenry himself is an asset to the nation. So you can contribute to the nation either as a businessman, as a philanthropy, or as an intellectual or an intelligentsia. So make sure that whatever you have learned, so if it is reaching to the people in one or the other way, so that is itself the true spirit of civil services. So it is not just wearing a uniform or a badge. So it is that whatever you have learned, so it should be useful for the nation to become a better place in this world to live in. So do it. All the very best. Good luck, friends.